Hi guys, so today we're going to be doing 1-2 properties of real numbers, right? So again, I highly suggest that as we're going over these examples, you're following along in your book just to also pause the video and to complete your vocab, because I'm not going to necessarily go over vocabulary since again, most of it should be familiar to you from pre-algebra, algebra 1, and geometry, okay? So if you're following along in your book, before we get to our first examples, you should be seeing the definition for real numbers, right? They're the numbers that you use in everyday life. It might ask you for some examples, right? Here, it can be real numbers can be classified as either rational or irrational, right? You're going to write the definition of rational numbers, maybe give some examples, give some definition of irrational numbers, give some examples as well, okay? Then, this part is super important in your book. It kind of gives you a Venn diagram, a visual to see where our numbers fall under, right? And then here it's also going to give you the symbols that we use for our different numbers, right? So R is for real, Q is for rational, I is for irrational, Z is for integers, W is for wholes, N is for natural. That way when you're looking at your answer key and you're wondering why did they put a Q when I wrote rational number, it's because Q represents rational numbers. Okay, so that's important to realize as well. Okay, so after that, you'll see it's example 1. So now we're going to get started with example 1. Okay. So here, example 1 wants you to classify the numbers. We want to name the set of numbers to which each number belongs. So here we're going to start off with square root of 16. Hopefully in your head, once you saw that square root of 16, you automatically simplified it to 4, because that would help you a lot, right? And so 4 falls under the real numbers, right? Because real numbers is generally the numbers that we use. If it's not a real number, it's an imaginary number, which we'll learn later is the square root of -1 or a square root of a negative number. Okay? So 4 is part of our real numbers. Okay. It is also considered a rational number, a ratio. It can be written as a ratio or a fraction, right? I could write 4 as 4 over 1. Okay. If it's rational, that means it can't be irrational. Okay. It is also part of our integer family, right? Integers are basically 0, 1, 2, 3, 4, 5, 6, and their negative counterparts. Okay. This is also a whole number. Okay. Whole numbers go from 0, 1, 2, 3, 4, 5. And then the natural numbers are similar to whole numbers. It's just whole number has 0 included, whereas natural does not. Okay. So moving on with -18. Okay. So -18 also falls under our real number. Right? It's part of our everyday usage. Okay. It is also considered an rational number. I can write it as a fraction as -18 over 1. It is also part of our integer family. Okay. However, it is not a whole number because it's negative, and it's not a natural number because it's negative as well. Okay. Okay. So the next one is square root of 20, right? So square root of 20, even though you can simplify it to 2 rad 5 or 2 square root of 5, you'll see that if you enter it into your calculator, it is technically a decimal. I don't know if you can see it. It's a decimal that goes on forever and ever and ever and ever and ever. Right? So square root of 20 is part of our real number family because it's not imaginary. However, it can't be written as a fraction of integers. So, and because it's a decimal that goes on forever with no pattern and no repeat, it is considered an irrational number. So that would be I. Okay. And since it's part of the irrational, it can't be part of any of the other integer families or other real number families like integers, wholes, and naturals. Okay. Next one is -7 over 8 or -7/8. Okay. This is a real number. Okay. This is also a rational number. You can see it is written as a ratio or a fraction, right? 7 over 8. So it's also a rational number. However, it is not an integer. It is not a whole number, and it is not a natural number either. Okay. Next one is 0.45 with the bar over it, which means that really it's 0.4545454545, etc., etc., etc. Okay. So here, this is part of our real number family because it's not imaginary. It's not a square root of a negative. Okay. Even though it's not written as a fraction, I can rewrite it as 45 over 99, right? You might remember how to rewrite it as a fraction from pre-algebra and algebra 1. Okay, because it's able to be written as a fraction or a ratio of two integers, it is considered a rational number. Right? However, because this is a decimal, it is not part of our integers, whole, or natural. Okay, so that's it. Next, you're going to try your check your progress 1A, 1B, 1C, enter your answer in, and then come and check your answer. Okay, here are the answers that you should have gotten. If you got it correct, you can move on into the video, skip ahead to example 2. If you didn't, then you probably would like to listen to the explanation. Okay, so negative 185 is part of the real number family. It's not imaginary. It's not the square root of a negative number, right? It is part of our rational family because I can write it as a fraction of integers, right? This could be 185 over, or divided by negative 1. Okay. And then this is also an integer. There is no fraction. There is no decimal here. Okay. For 1b, you should have simplified the square root of 49 to 7. So this becomes negative 7. That makes it a little bit easier now. Negative 7 is part of our real number family, right? It's not the square root of negative. The negative isn't inside, right? It can be written as a ratio. Okay, right? This could be negative 7 over 1. Okay, so that's a ratio, so that's why it's rational numbers. And then no decimal here, so that's why it's part of our integer family as well. Okay, 1c, square root of 95, it is not a perfect square, which means that it's a decimal that keeps on going forever and ever and ever. No repeats, no pattern. Okay, so even though it's part of our real number family, because it's not a square root of a negative number, it, however, cannot be written as a ratio, okay, and so that's why it is irrational. Okay, so that's 1A, 1B, 1C. Okay, moving on to example 2. Okay, so example 2 here, it says to name the property illustrated by this here. So probably what you should be doing is in your book, you should be noting the real number properties, right? This is what we're going to be using, okay? For me, the commutative property, how I like to remember, it is commutative, means it's moving, okay? And so note the position of them moved, right? From A plus B, it has now become B plus A. From A times B, it now has become B times A, right? So the numbers, or in this case, variables, have moved, okay? Associative property, how I remember that is association. Okay, associations are normally groups of people or a group of something, right? So here for associative property, what I think is that the association or the grouping has changed, right? So note here in the first half of the equation, the grouping was A plus B. However, after the equation, instead of the A plus B being grouped now, it's the B plus C that's being grouped. Okay, so the associative property is where the grouping has changed. Okay, identity property is often something is itself, right? So A plus 0 for the addition, noting adding 0 doesn't change its identity, right? So A adding 0, it is still A, right? And so the multiplication version, right? A times 1, the times 1 doesn't change anything. A times 1 is still A. It doesn't change its identity. Okay. Inverse property, we often talk about it when we're solving as canceling things out, right? So A, for the addition, to cancel it out, we do the opposite or the inverse of it, which is negative A. Note they cancel out to be 0. Okay. But for multiplication, instead of canceling out to be 0, we cancel out to be 1, right? And so that's why the inverse for multiplication is multiplying by its reciprocal often. right? So a times 1 over a is 1, right? Because no, it's canceling out or it's doing the opposite of it, okay? And distributive property, you probably know that pretty well. We're distributing the thing by multiplying it in, okay? So there you go. So let's move on to example 2. So name the property illustrated by 5 plus 7 in parentheses plus 8 equals 8 plus 5 plus 7. Okay, so here I see a grouping. However, the grouping did not change, right? Note that in my parentheses, it's still the 5 plus 7. Okay, however, where the plus 8 is has changed, right? So before it was the 5 plus 7 plus 8, and now it's 8 plus the 5 plus 7, okay? So here, since we moved, this is the commutative property, right? Because to commute somewhere is to move, right? To commute to work, commute to school. Commutative property, and then here, since it's addition, this is the commutative property of addition, okay? Just because there's grouping does not mean it's association, because note the association, the grouping never changed. It was always 5 plus 7 in that grouping. Okay, so here you're going to do your check your progress 2, okay, and then enter your answer and then type it in. Okay, you should have gotten distributive property. If you did, move on to example 3. If not, here's your explanation, right? So here I have 2 times, in parentheses, x plus 3. And note, I distributed the 2. 2 times x becomes 2x. 2 times 3 is 6. I distributed the 2. This is the distributive property. Okay? And then moving on to example 3. So here we want the additive inverse and the multiplicative inverse. Okay? So for additive inverse, what you want, right, is that you just want the opposite sign of it, okay? So the additive inverse, I spelled this wrong, additive inverse of negative 1 3/4, easy, change the sign, positive 1 3/4. How do I know? Because if I add these two, it now becomes 0. It cancels out, all right? Okay. Multiplicative inverse, you want the reciprocal, okay? So what's going to happen is I want to first change this into an improper fraction. It's now a mixed number. I want to change it to an improper fraction. So negative 1, or sorry, ignore the sign for now, okay? 1 times 4 is 4, plus 3 is 7. So this is 7 fourths, okay? And then I'm going to keep the negative, okay? So the multiplicative inverse, I want it to cancel out. So how I cancel it out, I just do the reciprocal. So all I do is flip the 7 and the 4. So now the 4 goes on top, the 7 goes on bottom. It's going to stay the same sign. Okay? So that's it. The multiplicative inverse is negative 4 sevenths. Negative 7 fourths times negative 4 sevenths would equal 1. Okay? There you go. Okay, so here you're going to try out 3A and 3B and then check your answer. Okay, these are the answers you should have gotten. If you got these correct, you can move on to the next example. If not, this is the explanation. Okay, so 3A, the 1.25, that one might have been a little bit hard. Okay, actually, let's just both talk about the additive inverse. Additive inverse, you're just changing the sign, right? So that's why for the additive inverse of 1.25 becomes negative 1.25. Additive inverse for 2.5 becomes negative 2.5. Okay. Multiplicative inverse is the reciprocal of that number. Okay. So for 1.25, it's hard to do the reciprocal of it. So what I did is I changed it into a fraction. 1.25 is 1 1/4. Okay. I changed it into an improper fraction. So 1 times 4 is 5. So 1 times 4 is 4 plus 1 is 5. So 5 fourths. And then I just flipped it, which is 4 fifths. And 4 fifths, this is a fraction you should know automatically as a decimal, that's 0.8. Okay. For the 2.5, right, 2 times 2 is 4 plus 1 is 5, so 5 halves. And then all I did is I flipped it, so 5 halves flipped is 2 fifths for the multiplicative inverse. Okay. There you go. Okay, and then now we're going to be moving on to example 4, which is our real world example. Okay, so moving on to example 4. Here, a restaurant adds 20% tip to the bills of parties of 6 or more people. Okay, so whenever there's 6 or more people eating together, they're going to add a 20% tip. Okay? So suppose a server waits on 5 such tables. So there's 5 of these tables that have 6 or more people. Okay? The bill without the tip for each party is listed in the table here. Okay? We want to know how much did the servant make in tips during this shift. Okay? I'm going to do it one way. The book shows you 2 ways, so I'm going to do it one way, and then afterwards I'll show you the way the book shows both of them. Okay? So one way we can do it is we can take each of them and multiply it by 20%. Okay? So hopefully we know that 20% written as a decimal is 0.20 or 0.2. Okay? So I'm going to take each of these and I'm going to multiply it by that 20% or the 0.20. So I'm going to start with my 185.45 and then I'm going to multiply it by the 0.20. Okay, that's party 1. Okay, then I'm going to do party 2, 205.20 times my 20% tip. Okay, that's party 2. Then I'm going to do party 3 plus 195.05 and then the 20% tip. Okay, that's party 3. Then I'm going to move on to party 4, which is 245.80 and their 20% tip. That's party 4. And the last is party 5, which was $262. And then I'm going to multiply the 20% tip. Okay. Now let's multiply. Okay, so 185.45 times 0.2 is 37.09. Yeah. 205.20 times 20% is 41.04. Okay. 195.05 times 0.2 is 39.01. Okay. Then the next one here is 0.2 times my 245, that's 49.16. And then my last one, my 262 times 20% is my 52.40. Okay. Then I'm going to add them all up and it becomes 218.70. Okay. And so how much did the server make in tips during the shift? The server made $218.70 in tips. So this is one way to do it. If you look at your book, that is method 1, right? So the way I just did it is method 1. The other way you could have done it is you could have added all of the bills together. That's what they did here. And then after you multiply that total by 20% or 0.2 and you would get the same answer. Okay? That's example 4. So here you're going to try your check your progress number 4. Once you have it, enter your answer in and then come back to check. Okay, you should have gotten $100. If you got it right, move on to example 5. If not, here's the explanation. Okay. Kayla makes $8 per hour working at a grocery store. The number of hours Kayla worked each day in 1 week are 3, 2.5, 2, 1, and 4. How much money did Kayla earn this week? Okay, so I did it in 2 ways. This is method 1 from the book. This was method 2. Right? So this method 1 is it takes each hour and multiplies it by 8. Right? So 8 times the 3 hours plus 8 times the 2.5 hours plus 8 times the 2 hours plus 8 times the 1 hour plus 8 times the 4 hours. That's how much we know that she'll make each day. Right? Then, after I multiplied it, I got 24, 20, 16, 8, and 32. I added it all together, and then I got 100. Okay? If you did it the other way, what you would do is you would add up all the working hours first, right? So 3 plus 2.5 plus 2 plus 1 plus 4, so that's 12.5 hours she worked that week. If it's $8 per hour, so 8 times that will give you also the 100. Okay? Okay, last example is example 5. Okay. We're simplifying an expression. Okay, so I don't know how else to explain it other than you want to make it as simple as possible, right? So oftentimes it means getting rid of parentheses and combining like terms. Okay, so that's what I'm going to do. The first thing I'm going to do here is I see some distributive property going on, so I'm going to distribute starting with a 2. Okay. So 2 times 5m is 10m, okay, and then 2 times n is 2n. Okay, so that's that one. Okay. Then I'm going to do the other one. Okay. So plus 3, so 3 times 2m is 6m, so positive 6m. 3 times negative 4n, 3 times negative 4 is negative 12, so negative 12n. Okay, so now, note, because I distributed, I got rid of the parentheses. Okay, then I'm going to combine like terms. Okay, so here, like terms, if you looked at the definition earlier, like terms should have the same variables to the same degree or same power. Okay, so here I have m's and n's both to the first degree. So here 10m and 6m, those are like terms. 10m plus 6m is 16m. Okay. And then the other thing that have like terms is the n's. So 2n minus 12n. 2n minus 12n, I now have negative 10n. Okay. And there is my answer, 16m minus 10n. Okay. You're going to do your check your progress 5, enter in your answer, and then come and check it. Okay, for your answer, you should have gotten 6x minus 8y. If you got that correct, that's it for today. Have a great rest of the day. If not, here's the answer or the explanation. So here I see I have some distributive property going on, so I'm going to start by distributing it. 3 times 4x is 12x. 3 times negative 2y is negative 6y. Okay. Negative 2 times 3x is negative 6x. Negative 2 times y is negative 2y. Okay. Now I'm going to combine like terms if possible. Okay. So again, like terms have to have the same variable raised to the same power. Okay. So here x to the power of 1, so 12x minus 6x is 6x. Negative 6y minus 2y becomes negative 8y, so that's why it's 6x minus 8y. Okay. That's it for today. Have a great rest of the day. Bye, guys.